Hello, and welcome to Knowledge to Fall Asleep To. I'm genuinely glad you found your way here tonight. For the next little while, we're going to drift quietly, gently, into the deep heart of the stars, the universe's great engines, its ancient furnaces of light. These glowing spheres are not just pretty points scattered across a dark ceiling. Some are so immense they could swallow the entire orbit of Earth as if it were dust. Others collapse into tiny remnants, dense, furious cores that spin hundreds of times a second like cosmic blades humming in the dark. And every one of them, in its own way, is a forge, shaping the elements that became our bones, our oceans, our mountains, and the breath moving in your chest right now. When you look up at the night sky, you are also looking backward through time. The starlight reaching your eyes tonight may have left its source hundreds, thousands, even millions of years ago. Some of those stars are already gone, extinguished, yet their light still travels on, a soft echo of something that once existed. Others will keep shining long after our world has turned silent. If you enjoy these slow journeys, you can tap like, subscribe, or leave a thought in the comments. It helps more people discover this place, one calm soul at a time. But for now, you don't need to do anything at all. Just rest. Let your shoulders soften. Let your breath loosen its grip. Let your thoughts float farther apart, like clouds thinning into a clear sky. And when you're ready, we'll begin. The largest stars we know are big enough to swallow Earth's entire orbit. Their scale is almost impossible to hold in the mind. One red hypergiant, for example, has a radius more than 1,700 times that of our Sun, so vast that if it sat at the center of our solar system, its outer atmosphere would stretch beyond the path of Jupiter. Even smaller supergiants, names you may have heard whispered in documentaries like Betelgeuse and V. Canis Majoris, could still consume Earth's orbit completely, as if our planet were nothing more than a spark caught too close to a bonfire. These giants are rare. They burn their fuel with reckless speed and live fast, only with a familiar steadiness. But a few extreme objects pour out energy on a scale that feels almost unreal, radiating more light than billions of suns combined. Luminous blue variables like Eta Carinae can unleash staggering amounts of power, rivaling the brightness of small galaxies. In the 1800s, Eta Carinae erupted so violently that, for a short time, it became one of the brightest stars in the night sky, despite being more than 7,000 light-years away. Stars like this, live on the edge, consuming hydrogen at astonishing speed, blasting their outer layers away with relentless stellar winds, often ending in catastrophic supernova explosions. And then there are the ghosts, neutron stars, the collapsed hearts of dead giants. When a massive star reaches the end of its life and detonates as a supernova, its core can fall inward and become something extraordinary. Neutron stars are only about 20 kilometers across, yet they can contain more mass than our Sun. The collapse squeezes atoms so violently that protons and electrons fuse into neutrons, creating matter denser than anything we know, except the interiors of black holes. A single teaspoon of neutron star material would weigh billions of tons. Their surfaces are hard, their gravity ferocious, their magnetic fields beyond imagination, and even though they are small, they are not quiet. Many neutron stars shine by blasting beams of radiation through space, or by heating their surroundings with leftover energy, proof that even after a star dies, its core can remain a powerful presence in the universe. Neutron stars are the universe's reminder that physics can be pushed to places that feel like myth. Some neutron stars become pulsars, cosmic lighthouses spinning at impossible speeds. They rotate hundreds of times per second, sweeping beams of radio waves or light across space. From Earth, those beams arrive like a heartbeat. Pulse, pulse, pulse. Steady enough that astronomers use them as cosmic clocks, sometimes more precise than atomic standards. The fastest, called millisecond pulsars, can spin more than 700 times per second, faster than a blender blade. When pulsars were first discovered in the late 1960s, their regular signals were so eerily precise that some briefly wondered whether they could be messages from extraterrestrial intelligence, until the true nature of these objects became clear. Today, pulsars help test Einstein's relativity and even assist in the search for gravitational waves. And then, at the far edge of extremity, there are magnetars, neutron stars with magnetic fields so strong they can tear atoms apart. Their fields can be 1 trillion times stronger than Earth's. If a magnetar came close enough, it wouldn't just pull on metal. It would begin to distort the very structure of matter. When their magnetic field shifts suddenly, magnetars can unleash enormous bursts of energy, releasing more power in a fraction of a second than our sun produces in hundreds of thousands of years. Some of these flares have been detected across vast distances, briefly shining brighter than all the stars in their galaxy combined. Thankfully, magnetars are rare, and none are close enough to threaten Earth. But as natural laboratories, they show us what happens when the universe pushes physical law to its breaking point. Not all stars are perfect spheres either. When a star spins extremely fast, centrifugal force makes its equator bulge outward, flattening it into an oval-like shape. One famous example is the star Achernar, which rotates so quickly that its equatorial diameter is dramatically larger than its pole-to-pole diameter. Rapid rotation can even fling matter outward, forming disks of gas around the star. From far away, such stars still sparkle like any other, calm, distant, ordinary. But up close, they are stretched by their own speed, shaped by motion as much as by gravity. And sometimes the universe doesn't let a star die peacefully at all. A star that drifts too close to a black hole can be pulled apart in a violent tidal event. Gravity's uneven grip stretches the star like soft candy until it tears into streams of glowing debris. That matter spirals inward, forming a brilliant, superheated disk as it falls, sometimes producing a flare that briefly outshines the combined light of every star in an entire galaxy. These events are rare, but they offer astronomers a way to study black holes that would otherwise remain invisible. Each one a sudden flash of destruction, a bright funeral in the dark. Stars can also collide, and when they do, the universe can ring like a bell. When two neutron stars spiral together and merge, they can release energy not only as light, but as ripples in the fabric of space and time itself. Gravitational waves. In 2017, astronomers detected gravitational waves from such a collision and then observed the event across the electromagnetic spectrum. Gamma rays, visible light, and more. It was the first time humanity witnessed both gravitational waves and light from the same cosmic catastrophe. These mergers also forge heavy elements like gold and platinum, scattering them outward, seeding the universe with materials that can one day become planets and lives and stories. Some stars don't even remain in their galaxies. A few are flung out at extreme speeds, escaping the gravitational pull of their home galaxy and wandering alone through the vast darkness between galaxies. They may be ejected by close encounters with supermassive black holes or chaotic interactions inside dense star clusters. Imagine a lone sun traveling endlessly through intergalactic space, carrying whatever remains of its planets into a silence so deep it's hard to picture. Astronomers believe there may be many such wanderers, embers blown away from the fire, drifting through the cosmic sea. In the earliest universe, the first stars may have been enormous, hundreds of times the mass of our sun. These primordial stars formed before heavy elements existed, when cooling was difficult and gas clouds grew into giants quickly. They burned fiercely and died young, exploding as immense supernovae that created the first carbon, oxygen, and iron, ingredients that later allowed planets, oceans, and life to exist. None of those first stars remain today, but their fingerprints may still be found in the ancient chemical patterns of the universe. And far ahead in time, the universe may grow quiet. Stars like our sun will eventually shed their outer layers and leave behind white dwarfs, hot, dense cores that shine from leftover heat. Over unimaginably long spans, billions and trillions of years, white dwarfs will cool and fade, becoming theoretical black dwarfs, cold, dead stars emitting no light at all. None exist yet, because the universe itself isn't old enough. But the idea points to a distant future, a long twilight, where the last lights go out, and the cosmos becomes darker and stiller. Yet even that isn't the end of wonder. Some theories suggest new stars could form again in future cosmic cycles. New universes, new beginnings, a rhythm of collapse and rebirth, highly speculative, yes, but comforting, strange way. A vision where starlight doesn't truly vanish, only transforms, passing forward through realities we can barely imagine. And for now, right now, we live in a kind of at the hearts of galaxies, hidden behind curtains of dust and distance, sit black holes millions to billions of times more massive than the sun. What feels most unreal is not only that these monsters exist, but that stars can survive in their vicinity, looping around them in paths that press gravity to its limits, like sparks circling the mouth of a furnace and somehow not being swallowed. In our own Milky Way, astronomers have watched stars race around the region of Sagittarius A star, the supermassive black hole at the galaxy's center. One of the most famous is the star S2, which swoops in to within about 17 light hours of the black hole at closest approach. Cosmically speaking, a hair's breadth. At that nearest point, it tears through space at more than 5,000 kilometers per second, fast enough to make the idea of orbit feel like a polite word for a near miss. Tracking these orbits is more than a spectacle. It's a laboratory written in starlight. By measuring how S2 and other stars move, scientists can weigh the black hole with extraordinary precision and test Einstein's prediction that gravity bends not only matter, but space and time themselves. These stars persist in a place we might assume would shred them. Proof that even near the shadow of a black hole, light can keep moving and motion can keep singing. And sometimes the fastest stars don't remain bound at all. A close encounter with a black hole does not always end in destruction. In rare cases, gravity becomes a slingshot. A star can be seized, whipped around, and then flung outward at tremendous speed, accelerated by the black hole's overwhelming pull, then released like a stone from a cosmic catapult. These are hypervelocity stars, racing at such extreme velocities that they can escape their home galaxy entirely, shooting out into the dark between galaxies. The Milky Way holds a few of these runaway suns, lonely travelers launched from the region near Sagittarius A star, where the central black hole and dense stellar interactions can turn gravity into a weapon. If a star like that once had planets, the result would be surreal beyond words. A drifting solar system hurled away from the familiar spiral arms, carrying its worlds into an exile measured not in miles, but in emptiness. The discovery of these wanderers reminds us that black holes don't only shape what falls in, they also shape what gets thrown out. Many single stars you see are not single at all. To the naked eye, a star looks like one clean point of light. But in truth, many of those points are families, binary pairs, triple systems, even larger gravitational communities bound together and dancing around a shared center of mass. Binary stars are especially common. Two suns locked in orbit, sometimes so close they exchange matter, sometimes so far apart they take centuries or millennia to complete a single revolution. Imagine standing on a planet in such a system. Your sky might hold two dawns, two sunsets, twin shadows sliding across the ground, and one of the most famous examples sits right next door. Alpha Centauri, our nearest stellar neighbor, is a triple star system. By studying these pairs and groups, astronomers learn how stars are born, how they age, and how they influence one another. What seems like a solitary ember in the night is often a hidden choreography, quiet, enduring, and impossibly graceful. A star's death can ignite the birth of new stars. When a massive star ends in a supernova, it doesn't simply disappear. It reshapes the space around it. The explosion sends shock waves into nearby clouds of gas and dust, compressing them, stirring them, pushing them past a threshold until gravity takes over and new stars begin to form. In that way, the death of one sun can become the cradle for many others. Our own sun may have been born from such a story, a cloud enriched by earlier supernova, seeded with heavy elements forged in older stellar hearts. These cycles keep galaxies luminous, continually recycling matter into fresh forms. A star does not vanish. It hands off the torch, leaving behind not only ash but possibility. Future suns, future planets, perhaps even future life. And some stars, in rare defiance, seem to explode more than once. Most supernovae are final, but a handful of massive stars behave like the universe itself is arguing with certainty. In extremely rare cases, a giant star can erupt violently, survive, and then erupt again years or decades later. Events often linked to a phenomenon called pulsational pair instability, where a star becomes unstable, blasts off huge shells of matter, temporarily steadies, then destabilizes again. To an observer, it can look like repeated supernova-like outbursts from the same point in the sky, a star flickering between survival and surrender. These strange, stuttering deaths reveal how diverse stellar fates can be, and how much we still have to learn about the limits of fusion and instability. They are cosmic dramas, stars that seem unwilling to let go, leaving behind a brilliant or trembling trail as though wrestling gravity itself for one more breath of light. Type 1. A supernovae help us measure the size of the universe. Among the most important supernovae are Type 1a explosions, remarkably consistent in their peak brightness. They occur when a white dwarf in a binary system accumulates too much material from its companion, triggering a runaway thermonuclear explosion. Because these blasts ignite at nearly the same critical mass each time, their maximum brightness is predictably similar across the cosmos. That makes them standard candles, reliable beacons that astronomers use to measure vast distances. Compare how bright a Type 1a appears from Earth with how bright it truly is, and you can calculate how far away it must be. These explosions played a crucial role in one of the greatest modern discoveries in astronomy, evidence that the universe's expansion is accelerating, driven by what we call dark energy. In other words, these are not only spectacular endings, they are measuring sticks for infinity, helping us map the scale and fate of the cosmos. Supernovae scatter heavy elements across the galaxy. Every atom of iron, calcium, silver, and gold on Earth came from stars. Some were forged slowly in stellar cores. Others were born in the violence of stellar death, hurled into space by supernovae, mixed into the interstellar medium, and later gathered into new stars and planets. Without supernovae, the universe would be far simpler, mostly hydrogen and helium. Instead, every explosion seeds complexity. The iron in your blood and the calcium in your bones were once part of a star's inner life, then carried outward in an ancient blast, drifting through space until they became part of a world that could grow trees, oceans, and human hearts. Supernovae are brutal endings, yes, but they are also beginnings, distributing the ingredients of life across the dark like a promise. You truly are made of stardust. It sounds poetic, but it is scientific. The oxygen you breathe, the carbon in your cells, the metals in your blood, these were created in stars and spread by stellar death. Long before Earth existed, those atoms won their glow blended with ours beneath a different arrangement of constellations, a different map of familiar shapes that no human eye ever saw. And as the sun continues its long orbit around the Milky Way, that map will keep changing. The starry companions around us will drift, swap places, fade from relevance, and slip away beyond sight, replaced by newcomers arriving from other regions of the galaxy. This quiet migration reveals something deeply humbling. Even the sun's address is temporary. Our position is not an anchor. It is a moment, one frame in a vast rotation that carries us through the galactic sea. To look up at the night sky is to witness a snapshot of an endless journey, where the travelers beside us come and go across ages, like passing lanterns on an ocean too wide to measure. Some of the oldest stars in the universe live inside globular clusters. These are dense, spherical swarms of starlight, often hundreds of thousands of stars packed into a relatively small volume, circling galaxies like glittering satellites at the edge of the night. Each cluster is a fossil from the early universe. Many globular clusters in the Milky Way are more than 12 billion years old, nearly as ancient as the universe itself. Their stars are often small and long-lived, dim red dwarfs and steady elderly suns, while the most massive, brilliant stars burned out billions of years ago. Through a telescope, a globular cluster can look like a radiant snow globe, so crowded at the center that individual stars blur into a bright core, a concentrated glow that feels almost solid. They are more beautiful than we expect because they are not just scenery. They are doorways into deep time. Studying them is like reading a history book written in starlight, following the early chapters of our galaxy, page by page, photon by photon. And hidden among younger generations of stars are a few true elders, ancient Milky Way stars nearly as old as the cosmos. Some appear to be more than 13 billion years old, formed from primordial gas that contained almost no heavy elements. Astronomers identify them by studying their spectra, the chemical fingerprints etched into their light, searching for signatures that have changed little since the early universe. These stars are rare, but they are priceless, living relics from an era when the universe was still young, still dark, only beginning to glitter with the first fires. To gaze at one is to feel time deepen beneath your feet. It is like touching an artifact from the dawn of existence, something that survived the long night before galaxies fully bloomed and heavy elements filled the cosmos with complexity. Stars can outlive the very galaxies that once cradled them. Galaxies are not static islands. They collide, merge, tear, and reshape under gravity's slow insistence. Yet many stars endure beyond those transformations. A star born in a small galaxy can be swept into a larger one during a merger and continue shining for billions of years under a new sky. Some may even be thrown into intergalactic space, wandering alone long after their original galaxy has been disrupted or absorbed. In that way, stars become cosmic witnesses, survivors that outlast the structures that created them. Their light persists longer than the cradle that first ignited it. Some stars wear mysterious shells of gas like luminous veils. Not every star shines naked against the dark. Many undergo unstable phases where they shed matter into space, gas and dust expelled by fierce winds or violent eruptions. These ejected layers can form rings, arcs, and glowing bubbles, illuminated from within by the star's radiation. In some cases, astronomers see multiple shells, stacked like geological layers, evidence of repeated episodes of loss and upheaval. These shells are not merely decoration. They enrich the galaxy with elements that will later form new stars and planets. To study them is to catch a star in the act of becoming something else, draped in radiant curtains that preserve the story of its past. Wolf-Rayet stars live on the edge. They are rare, massive, and ferociously unstable, so hot and bright that their outer layers are blasted away by violent stellar winds. These winds can carry off enormous amounts of material, sculpting dramatic halos of gas and dust around the star. With exposed cores and surface temperatures that can exceed tens of thousands of degrees, Wolf-Rayet stars burn like cosmic blowtorches, sprinting through a short, intense life before collapsing into supernovae or even black holes. Though uncommon, they are crucial architects of chemical richness. Their winds and eventual explosions scatter the raw materials of future worlds. They are stars that blaze so intensely they cannot last. Flames that know their ending is close and shine all the harder because of it. Some fast-moving stars carve bow shocks through space, like ships cutting water. When a star races through a dense region of gas and dust, it can compress that material into a glowing arc ahead of it, a shock front shaped like a crescent. Seen in infrared light, these bow shocks reveal the star's motion and the density of the medium it's traveling through. Many of these stars are runaways, ejected by supernova blasts or gravitational chaos, leaving behind a bright, fleeting signature of their speed. Each bow shock is like a frozen wave in space, a luminous footprint marking a star's relentless journey across the galaxy. The youngest stars are often hidden behind dust. Newborn stars rarely reveal themselves at once. They form inside thick molecular clouds, their natal cocoons, where visible light is smothered and swallowed. Astronomers use infrared and radio observations to pierce the veil and find embryonic clusters still gathering mass. Often these young stars are surrounded by disks of material that may one day form planets. Over time, radiation and stellar winds clear the dust away, and the star emerges, finally shining freely. To witness a newborn star is to witness creation in motion, a fragile, fleeting phase, brief on the scale of a star's life, yet breathtaking in what it promises. Even before fusion begins, a forming star can glow. A star does not ignite immediately. Before it becomes a true star, it exists as a protostar, a collapsing knot of gas heated by gravity itself. As it contracts, it shines faintly from gravitational energy, gathering more matter, sometimes launching jets from its poles that pierce the surrounding cloud like narrow spears of light. Only when its core reaches roughly 10 million degrees does hydrogen fusion begin, and the protostar officially becomes a star. That hidden stage is the universe's quiet prelude, a slow gathering of destiny in darkness before the first stable starlight takes hold. Brown dwarfs blur the line between planet and star. Some objects are too massive to be planets, yet not massive enough to sustain stable hydrogen fusion like true stars. They glow weakly, and mostly in infrared, from leftover heat and brief episodes of deuterium fusion. They are difficult to detect, but astronomers have found many alone or orbiting stars, proof that the cosmos makes more kinds of almost stars than our simple categories can comfortably contain. In a way, they are failed stars or overgrown planets, a reminder that nature rarely fits neatly into human labels. Stars can merge and be which appear oddly young because they have been rejuvenated by the merger, pass from one another. As one star expands into a giant, its outer layers may spill toward its companion. The receiver can become hotter and brighter. The donor can be stripped down to a dense remnant. In extreme cases, this mass transfer can trigger novas or even supernova, turning a quiet gravitational relationship into one of the most dramatic fireworks in the sky. Binary stars are cosmic thieves and victims, bound together in long, luminous dramas that unfold over millions of years. Triple star systems can create strange, shifting orbits. Some stars come in threes, arranged in delicate gravitational hierarchies or complex patterns that can destabilize planetary orbits, tilt worlds at extreme angles, and create skies where day and night feel unfamiliar. These systems are surprisingly common, and they expand our sense of what a normal solar system even means. And yes, planets can orbit two suns at once. Science fiction imagined it, and astronomy confirmed it. Some worlds follow stable circumbinary orbits, looping around both stars together. Others orbit one star while the companion rises and sets like an uncanny second sun. Missions like Kepler revealed many such planets, proving that the architecture of planetary systems is far more diverse than we once believed. On those worlds, light would behave differently. Seasons, shadows, and darkness would follow rhythms unlike anything on Earth. Stars are often born in crowds, inside clusters. Some clusters contain hundreds of thousands of suns packed into tight space. where stars frequently interact, swap companions, and disturb planetary systems. Open clusters are younger and looser, often glowing with hot blue stars, bright signs of youth. Over time, open clusters disperse and their stars mix into the galactic disk. Many astronomers suspect our sun was born in an open cluster about 4.5 billion years ago, a family that has long since dissolved. Globular clusters, by contrast, can endure for billions of years, held together by their dense gravitational binding. They orbit like ancient relics, cosmic time capsules storing information about the early Milky Way, the chemical signatures of old stars, and the conditions under which galaxies first assembled. Some galaxies experience starbursts, forming stars at furious rates. While galaxies like ours produce stars steadily, our starburst galaxies ignite in waves, often triggered by galactic collisions, creating new stars hundreds or thousands of times faster than normal. Whole regions blaze like cosmic fireworks. These episodes don't last long on cosmic time scales, only tens of millions of years before the gas runs thin and the frenzy fades. But they reveal the universe's changing rhythm, sometimes calm, sometimes eruptive, always creating. And all of this returns us to the same quiet truth. The sky we know is not permanent. The constellations above you are not fixed decorations. They are a moving story, a temporary arrangement in a restless galaxy. We are travelers beneath a shifting ceiling of light, watching only one frame of an immense ongoing film. So breathe and let that be comforting. Even in a universe that never stops changing, the stars still offer something steady, a gentle glow, a patient rhythm, and the strange peace of knowing that you are part of the motion, carried softly through the Milky Way under a sky that is alive. They remind us of something tender and astonishing. Not every star that wanders near a black hole ends in tragedy. Some spend their whole lives as intimate companions of cosmic darkness, circling the unseen with stubborn grace, shining not in spite of the abyss, but beside it, as if the void itself could be lived with. And elsewhere, far from those violent hearts of galaxies, stars begin their lives wrapped in creation. When a star is young, it is often surrounded by a whirling disk of gas and dust, a slow luminous storm flattened into a spinning plain. Inside that disk, matter clumps, grains collide, pebbles become boulders, boulders become worlds. Over millions of years, entire planetary systems assemble, sculpted by gravity and the subtle push and pull of the newborn sun at their center. Astronomers have even imaged these disks directly, seeing dark gaps and carved rings where forming planets are already clearing paths. Proof that we are not imagining the process. We are watching construction in real time. Our own solar system began this way about 4.5 billion years ago. Stars and planets are born together. Their destinies are braided from the beginning. To study these disks is to study the origin of everything solid you have ever touched. It is a reminder that worlds are not miracles stitched in secret. They are the natural consequence of starlight, patience, and dust, learning how to become a home. The most massive stars, meanwhile, do not merely sit inside their galaxies. They reshape them. These giants pour out radiation and stellar winds so powerful they can hollow out the space around them, blowing vast cavities in the surrounding gas and dust. The result can be enormous bubbles, tens of light years wide, glowing along their rims where gas becomes ionized and lit like a thin, luminous shell. Inside, the winds sweep the region clean, carving an emptiness around the star like breath-clearing fog from a window. When many massive stars form together, their bubbles can merge into superbubbles, cathedral-scale structures that redraw entire neighborhoods of a galaxy. They are not only beautiful, they are influential. They compress gas along their edges, sometimes triggering the next generation of star birth. Yet from Earth, we see them as glowing shells inside nebulae, cosmic spheres inflated by the breath of giants. The message is clear. Stars are not passive lights. They are active sculptors, leaving their power etched into space itself. Sometimes, what looks like a star changing is really the universe between us and it moving. A star can seem to flicker because dust drifts through the line of sight, briefly dimming its light like a passing veil. When astronomers see a star fade and brighten unpredictably, the cause is not always the star's own heartbeat. Sometimes it is debris, clouds, clumps, fragments crossing in front of it. One famous example is Tabby's star, whose strange dips in brightness sparked years of debate and investigation, with dust and surrounding material among the leading explanations. These flickers teach humility. The universe is not an empty stage. It is filled with matter that can scatter, filter, and hide light. Even our sun, viewed from far away through a dusty plain, might look like it is blinking, its steadiness disguised by the fog between the observer and the source. What we see is never only about the light, it is also about the distance and everything living in that distance. And when a star truly is bright and hot enough, it can make an entire nebula glow like a lantern. Massive stars pour out ultraviolet radiation so intense it ionizes vast regions of gas, turning whole clouds into luminous architecture. The Orion Nebula shines because a cluster of young, massive stars at its core floods the region with energy. Their radiation capable of shaping the structure of galaxies across distances hundreds of light years wide. Most stars live inside galaxies, bound into enormous gravitational families, but some are cast out. A star can be flung away by close encounters with black holes, by violent gravitational interactions, or by the tidal chaos of galaxies passing too near each other. These intergalactic wanderers drift alone through the abyss between galaxies, far from any home, traveling at hundreds of kilometers per second. They can remain isolated for billions of years, their light crossing vast emptiness without touching another star system. The idea is haunting, a solitary sun exiled into silence, shining defiantly where there is almost nothing to shine upon. Yet even in loneliness, these stars become messengers. Their motion carries clues about the catastrophe that launched them, and their existence reminds us that even stars, symbols of permanence, can be displaced. And through all of this, the deeper truth remains. The elements inside you were forged long before you arrived. Inside stars, nuclear fusion turns hydrogen into helium, then helium into heavier elements, carbon, oxygen, nitrogen. In the most massive stars, that alchemy continues, silicon, iron, and beyond. And when these stars die, they scatter their creations into space, enriching future generations of stars and planets. Every breath of oxygen you take, every carbon atom in your cells, every trace of iron in your blood, each one was once part of a star's inner fire. Stars are cosmic alchemists. They turn simple gas into the building blocks of life. To look up at the night sky, is to look at your own origin story written in distant furnaces, light years away, eons ago. In a very real sense, you are stardust that learned to think, stardust that learned to feel. At their core, stars are vast nuclear fusion engines. Gravity crushes hydrogen so tightly that atoms fuse into helium, releasing energy as heat and light. It's the delicate balance between gravity pulling inward and fusion pushing outward can hold a star steady for billions of years. Without fusion, stars would collapse under their own weight. With it, they shine across impossible distances, power the evolution of galaxies, and warm worlds into possibility. When you see a star glittering, you are witnessing fusion, matter transforming into light, reaction by reaction, endlessly, patiently, turning the raw stuff of the universe into radiance. And the story does not end with a star's death. It changes form. When stars explode as supernovae or shed their outer layers, they seed space with heavier elements. That enriched gas mixes into the interstellar medium, gathers into clouds, and, over time, collapses again into new stars. Each generation inherits the legacy of the last. Our sun was born from the ashes of earlier stars. Future suns will be born from the remnants of today's. It is a cycle of death and rebirth so old and so reliable that it keeps the galaxy from ever becoming chemically or spiritually still. Some stars are born in starburst galaxies, places where creation becomes a frenzy. In these galaxies, star formation can run 100 times faster than in the Milky Way, often triggered by galactic collisions that compress gas into waves of furious birth. Entire regions ignite with young massive stars, their radiation flooding space with energy. The galaxy blazes in infrared light from the heat of countless new suns. But the frenzy cannot last. In a few 100 million years, the gas is exhausted or blown away, and the burst fades, leaving a galaxy permanently shaped by that brief, chaotic season of abundance. And not every star is born alone. Many are born in crowded nurseries, dozens, even hundreds forming side by side, tugging at each other's gravity, twisting orbits, swapping companions, scattering siblings. In those dense beginnings, stars can steal planets, fling rivals outward, or disrupt each other's growth. Yet, these turbulent environments are also where chemistry becomes richest, where shock waves, radiation, and stellar winds mix matter into complexity. To imagine a star's first moments is not to imagine quiet isolation, but a bright, noisy nursery where many suns flare together, competing, cooperating, and learning their roles in the galaxy. Even after a star dies, it can keep shining for an unimaginably long time. Stars like the sun will end as white dwarfs, Earth-sized remnants, no longer powered by fusion, yet still hot and glowing with stored thermal energy. They cool so slowly that the universe is not old enough for any white dwarf to have faded into a true black dwarf yet. Even death, in the stellar sense, can be a long afterglow, a quiet persistence that lasts for billions of years. Some stars die softly, others die violently. Small stars fade, massive stars explode. Some collapse into neutron stars or black holes, leaving behind the strangest objects in the cosmos. But every ending feeds a beginning. Every death becomes raw material. No star truly disappears without giving something back. And that is why the night sky feels both eternal and fleeting. The constellations look fixed, but time is always working. Stars are born, live, and vanish. Nebulae bloom, clusters drift, galaxies collide. and lone stars wander into darkness. Even our sun is temporary. It will expand, change, and fade one day. The universe is not still. It is alive with transformation. So if you are listening to this as the day loosens its grip, you don't need to hold every detail. Let it drift past you like stardust in a slow current. What matters is the feeling, vast quiet, gentle awe, the strange comfort of being small and yet profoundly connected. Because you are part of this universe, woven from the same substance as stars. And if this journey brought you peace, you can leave a like, subscribe, or share a thought below. It helps others find this quiet place, one person at a time. But right now, you don't need to do anything. Let your breathing soften. Let your body become heavy. The stars will keep shining. The galaxies will keep turning. And you can simply rest. Somewhere out there, a star is burning whose light will not reach Earth for thousands of years. By then, you will have dreamed 1,000 dreams, and the world will have turned countless times. The stars remind us that time is vast, but it can also be gentle, a current we can float upon. So let yourself float into the calm dark. Sleep well, dream deeply, and remember, starlight is not only above you. In a very real way, it is within you.